Hi everyone, let's go ahead and look at 3.2. I'm going to do example here, example 1 with a cell phone. So we have a cell phone that is charging at a constant rate, which means this is going to be a linear graph until the battery is full and can be represented by this function, B of t equals 1.5 t plus 10. T represents time, B represents that battery percentage. So how much battery is charged and what is the time that the battery, or how much the time, T is the time that the battery is charging in minutes. What is the rate of change and what does it represent? So when we are looking at this stuff here, let me cross something off here. I don't need this part right now. Okay, so scratch that part off. I don't think it's on your paper anyway, it's on mine. So if we have what is the domain, what is the range, and what do they represent? Well, let's go ahead and graph this first. So 1.5 is the rate of change, 10 is the y-intercept. So on the y-axis, the y-intercept is 0, 10. Now, these aren't counting by 1.5s or aren't counting by 0.5s. They're actually counting by 4s or by 2s on the x-axis, and they only show us 4, 8, 12, 16, and 20. And then on the y-axis, for the battery percentage, they're counting by 5s. So what I'm going to do is I'm going to take one of the x values. So I'm going to take 4, and I'm going to plug that into the equation. So I'm going to use substitution here. This is what we are evaluating. So 1.5 times 4 is 6, and 6 plus 10 is 16. So at 4 minutes, it is 16% charged. Now, the next time that I do this, I'm not going to do 4. I'm going to put the 8 in there. So after 8 minutes, 1.5 times 8 is 12. 12 plus 10 gives me 22. Now we can go through and check 12, 16, but the ones that I like to check when I'm doing something like this is I'll check the first one, which the first one is 0. So I'll check that one. I'll check the last one, and then I'll pick one somewhere in between there for the t value or the x value if you think of it that way. So we've already got 8 done. So let me go ahead and substitute in 20 into this same expression or equation. So 1.5 times 20, okay, so you got to do that part first, is 30, and then 30 plus 10 is 40. So after 20 minutes, the phone is 40% charged. Okay, now they're telling us that this is linear, so we want to make sure that it looks like a line, and it does. Now we have to determine a couple of things based on the question. It says a cell phone is charging, so in order to be charging, how many minutes can you let it charge for? Well, if it doesn't tell us to unplug it after it stops charging, some of us might say that it goes on forever and ever until the person unplugs it, and we don't know when that is. Others might say, well, we're only going to charge it until it's 100% full. Okay? So that all depends on which way you're looking at it. And again, you could argue either of those cases. So I'm going to go ahead and just say we left it plugged in. I don't know how long the person left it charging for, but I do know that it did start at 0 minutes, and it's going to be greater than 0 minutes. I can't charge less than 0 minutes. So the domain is greater than or equal to 0. And that is talking about minutes. Now when we're talking about domain, they didn't use x, they actually used t. If you use x, just understand that you want to show that t is equivalent to x, or that you change the variable. Now the next thing, it says what is the range? Well, the range is talking about the y values. So on this one, y is greater than or equal to 10% charge, because that's what it started with. It had a 10% charge when you plugged it in, so that's the minimum that it can get to. Now, even though we see this, how much can a phone really charge to? It can only charge to 100%. So it's not going to be that. It's actually going to be y. The battery charge can be between 0 and 100. Okay? So be really careful with that one, because we know that a phone cannot charge past 100%. Unlike the time, we didn't know how long they left it plugged in. So what does the y-intercept represent? Well, what is the y-intercept? The y-intercept is 0, 10. 0 is talking about minutes, and 10 is talking about the percent charged. So at 0 minutes, it's 10% charged. Okay, so then the last one. What is the rate of change talking about? Well, the rate of change is that slope in the equation. So on this one, the rate of change is 1.5. Now, we talked about this in class, that when we're talking about rate of change, we like to see this as a fraction. Well, they didn't give us a denominator. We could turn that decimal into a fraction. It would be 3 over 2. But if we just keep it the way it is, 1.5, I can put a denominator under it, and that denominator would be 1. Because 1.5 times 1.5 divided by 1 is still 1.5. So if I've got this here, then 1.5 is talking about the rise. That's talking about the percent. The 1 is talking about the run. The run is talking about minutes. So if I ask, what does this rate of change represent? It charges 1.5% every 1 minute. Okay? All right, let's go on to question number 2, or example number 2. Check your understanding. That one is yours for homework. Number 2, a printing machine produces 5 posters per hour, 50 posters already printed from a previous job. The printer will print for an entire 8-hour shift. Well, our equation is P of H equals 5 times H plus 50. Now, I'm not substituting 8 in just yet, because I want to be able to use H for any hour. How many posters are there after 1 hour, or after 2 hours, or after 3 hours? Ultimately, we're going to get to 8 hours. All right, so here at 0 hours, it's the y-intercept. So at 0 hours, they already had 50 posters to start. Now let's go ahead and substitute in 2 right here. 5 times 2 is 10. 10 plus 50 is 60. So after 2 hours, they've got 60 posters printed. Now what about after 8 hours? 5 times 8 is 40. 40 plus 50 is 90. Okay, make sure that it looks linear. If it looks linear, go ahead and draw your line. Now this one, they do tell us to go just up to 8 hours. Okay? So the domain for this one, the x values or the h values, are between 0 and 8. So this is talking about hours. Now the range, which is the y value, they could have 50 posters, and it can go all the way up to 90 posters. The y-intercept on this one is 0, 50, 0 for x, and 50 for y. The rate of change on this one, you can say m equals 5. You can say m equals 5 over 1. Either one that works for you. Okay. Now, if I'm using it as 5 over 1, I want to make sure I know what I'm talking about. So it's 5 posters for each hour. Okay. All right, let's go on to example number 3. Okay, that one. Oh, here we go. A swimming pool. So if I have a swimming pool is being drained at a constant rate. After 2 hours, it contains 2,400 gallons of water. After 5 hours, it contains 1,200 gallons. So 2 hours is 2,400. 5 hours is 1,200. Now, with 2 points, I can see that this is going to be a linear graph. So I'm going to go ahead and graph these two. All right, looking at this information here, the domain is the X values. So they started draining it at 0 hours, and at 7 hours, it was completely drained. So the domain is X is greater than or equal to 0 and less than or equal to 7. The range, now we're talking about these Y values. It can get down to 0 gallons, and it started at 3,200 gallons. So it is greater than or equal to 0, less than or equal to 3,200. Okay? So the domain is talking about hours, and the range is talking about gallons. So what is the y-intercept? Well, the y-intercept is 0, 3,200. So at 0 hours, there was 3,200 gallons of water in the pool. What is the rate of change? The rate of change, now to find that, we've got to calculate the rise over the run. So I'm going to see how many it actually goes negative, where it falls down. And I'm going to go from the points they gave us. So I'm not going to change anything here. Okay. How many did it fall down? So from 2,400 to 1,100, right? So each one is, to 1,000. So that is negative 1,400. How many hours went by? So they're counting by ones, so that's 3 hours. So the rate of change now we always want to check to see if we can reduce this, okay? And if we can, we will, but at least even if you decide to leave it this way, make sure again we know what we're talking about. So over 3 hours, the water reduces 1,400 gallons.